Good morning, my dear student. I am Bhupen Deshmukh, work as an assistant professor in Kekewa College of Engineering, Nasik. Today, I want to share very small topic that is full bridge VSI voltage source inverter. Here, DC supply converted into AC supply, and such inverter is called DC to AC, DC to AC inverter, DC to AC inverter. DC to AC converter. This is my content. Introduction of DC to AC converter, that is voltage source inverter, or we can say inverter. Classifications of DC to AC converter. Single phase full bridge inverter with R load. In this single phase full bridge inverter with R load, I will try to explain how to convert DC supply into AC supply, basic operation and working principle of DC to AC converter, and some applications of DC to AC converters. This is our learning objective about DC to AC converter. After going through this video or online lecture, you will be able to understand about basic introduction about DC to AC converter or inverters, general classifications of DC to AC inverters, and basic operation principle of DC to AC converter, DC to AC converter and their applications, how to convert DC supply into AC supply. Introductions. We know that in electrical domain, basically two types of supply. One is AC supply or second one is DC supply. AC and DC supply are used according to apparatus requirement. Sometimes AC supply convert into DC and DC supply convert into AC depending on the apparatus requirement and consumer requirements, and sometimes DC supply converted into AC supply, and as well as AC to AC convert and DC to AC conversion, DC to DC conversion. When DC supply converted into variable AC supply, such device or such equipment is called as inverter, and such converter is called as DC to AC converters. Inverter is a device which can convert a DC input supply into AC output supply of desired magnitude and frequency. It's called DC to AC converter, or we can say inverters. Here the output voltage is AC, or this output voltage is completely controlled their magnitude and as well as frequency. Any types of ideal inverter output waveform is purely sinusoidal, but practical inverter output waveform is non-sinusoidal, but the practical inverter output waveform look like a sinusoidal waveform, or we can say very closely to sinusoidal waveform. In general, ideal inverter is not existing in this universe, but practical inverter is existence in this universe. If input supply of DC voltage, it's called voltage source inverter, that is VSI. Once can once once can similar thing, if input supply is current source, that then it's called current source inverters. It means we can say the inverter is divided into two part. One is VSI and second one is CSI. If input supply, DC input supply is voltage form, we can say voltage source inverter. If uh, input supply of DC is current source, then we can say it is current source inverters. Some classifications of DC to AC converters. Broadly, inverter are classified into two types. One is voltage source inverter and second one is called as current source inverters. Now, different types of inverter based on their specifications or characteristics based on the supply. Inverter are two types: single phase inverter and three phase inverter. This single phase inverter further classified into two types, half bridge inverter and full bridge inverter. And three phase inverter further classified into two types, 180 mode operation three phase inverter and 120 mode three phase inverters. And based on the source supply, voltage source inverter and current source inverter. Based on the output waveform, square waveform inverter, sine wave inverter and modify sine wave inverter. Based on the different PWM techniques, single pulse width modulation techniques, that is SPWM inverter, multi-pulse width modulation techniques, it means MPWM inverters, sinusoidal pulse width modulations, SPWM inverters, modify sinusoidal pulse width modulations, it means MSPWM inverter. Based on the output level, regular two level inverter and multi-level inverters. This is the general classifications of DC to AC converter, or we can say converter classifications. This converter classifications based on their specifications and characteristics. The single phase full bridge inverter. This is the circuit diagram of single phase full bridge inverter. In this diagram, input side we are applying DC supply, and here I am using four switches: MOSFET 1, MOSFET 2, MOSFET 3 and MOSFET 4. And instead of this MOSFET you can use IGBT or any other types of semiconductor devices. When we are considering MOSFET 1 and MOSFET 2 is turn on conditions, and MOSFET 3 and MOSFET 4 are is turn off conditions. Under these conditions, the current is flowing this directions, and this diagram is a equivalent diagram of above MOSFET single phase full bridge inverter circuit diagram, and current is flowing these directions. Under this direction, we are getting the output voltage is this much amount. When thyristor, or we can say, sorry, when we can consider MOSFET 3 and MOSFET 4 is turn on conditions and MOSFET 1 and MOSFET 2 is turn off condition, then current is flowing this directions, and current is flowing this directions. This is the direction of current flowing. Under this two case, when MOSFET 1 and MOSFET 2 is turn on conditions, that case the load, resistive load, across the resistive load, here I am getting positive polarity and here I am getting negative polarities. When we are considering the MOSFET 3 and MOSFET 4 is turn on condition, then across the resistance we are getting here positive polarity and here I am getting negative polarities, right? Positive polarity and negative polarities. So during the MOSFET 1 and MOSFET 2, we are getting uh, across the load polarity is one directions, and during the MOSFET 3 and MOSFET 4 is turn on condition, across the load terminal we are getting polarity is different types. Then we can say this fixed DC supply converted into AC supply, and this fixed AC supply converted into DC supply is for better understanding. Under this slide we can understand how to convert fixed DC supply into variable DC supply. Here summarize, this is your input supply, and this is the first conditions when MOSFET 1 and MOSFET 2 is turn on condition, then output waveform is look like this. And when MOSFET 3 and MOSFET 4 is turn on condition, then we get the output waveform is look like this, and final output waveform is represented here. Now this is the input waveform and this one is a final output waveform. When we are comparing this input waveform and this output waveform, then we can say this fixed DC input supply converted into variable AC supply, and we can say This AC supply converted, sorry, this DC supply converted into AC supply. Such converter is called as a inverter circuits. For low power and medium power applications, we are required square wave and quasi square wave type of inverters, or we can say such types of inverter is acceptable. For high power applications and low distortion sine wave, low distortion, we are required to sine wave inverter are required using high power speed power semiconductor device. The harmonic content at output can be controlled by PWM techniques. Industrial applications of inverter, variable AC motor, induction heating, stand power supply, UPS, and as a input battery, fuel cell and solar cell are used in inverter. This battery and fuel cell and solar cells are used as a input supply in the inverter circuits. Thank you. If you have any doubt related to full bridge inverter, or we can say voltage source inverter, you can contact on my personal email ID and as well as on my YouTube channel. Comment on my YouTube channel. Please share and subscribe my YouTube channel. Thank you.